Physics, astrophysics, and astronomy are huge fields to study in. They can look at and answer almost any question, from the smallest subatomic particles to huge discoveries having an impact upon entire galaxies. So today, here at Unexplained Mysteries, we will be taking a look at 3 recent discoveries. Scientists detect the ghostly signal that reveals the engine of the universe. When we make a discovery that inches us a little closer to being able to confirm a theory, it's thrilling. But when we uncover something monumental, it is truly revolutionary to the field, to our history, and to our futures. Physics is a discipline that truly captures our understanding of the world. To advance our understanding of physics is to advance our understanding of everything we are surrounded by. In November of 2020, an article was published to the scientific journal Nature, in which scientists detailed their research, where they detected for the first time neutrinos that can be traced back to carbon-nitrogen-oxygen fusion. Carbon-nitrogen-oxygen fusion, otherwise known as the CNO cycle, is a process that occurs inside the Sun. Whilst to those of us who do not know all too much about physics, this particle is a truly iconic moment that will not be forgotten anytime soon. This finding can confirm theories and predictions we have been guessing at since the 1930s. Gioacchino Ranucci, a researcher at the Italian National Institute for Nuclear Physics, said it's really a breakthrough for solar and stellar physics. He has been one of the researchers tackling this project since it first began in 1990. Scientists were able to use the Borexino detector at the IFN's Gran Sasso Particle Physics Laboratory located in central Italy. This is an incredibly sensitive piece of equipment. It is the largest underground research center in the world and sits below the Apennine Mountains. The quest to hunt down this particle is the Borexino project, and uncovering the neutrino we have been looking for concludes decades of predictions and research. It has revealed to us the main nuclear reaction that most stars use to fuse hydrogen into helium. Most stars, including our very own Sun, emit massive amounts of energy by fusing hydrogen into helium. This is essentially a way to burn hydrogen. It is worth bearing in mind that hydrogen is the simplest and most abundant element in our universe, making it the main fuel source. For the Sun particularly, 99% of its energy comes from what is known as proton-proton fusion. This produces beryllium, lithium, and boron before they are broken down into helium. It's not always this clear and straightforward. Our Sun is not very big, at least not in comparison to some of the other stars in the universe. It's worth noting that typically the larger the star, the hotter it is. These are therefore powered mostly by CNO fusion. CNO fusion keeps an endless loop between carbon, nitrogen, and oxygen, as to which atomic nuclei facilitates the fuse of hydrogen into helium. By our calculations, the CNO cycle is the primary type of fusion in the universe. Unfortunately for us, in the star closest to us, the Sun, this accounts for only 1% of its energy. The Borexino detector searches for neutrinos that are produced in the nuclear fusion process at the Sun's core. This is a difficult process due to how hard it is to detect neutrinos. Using neutrinos to study distant nuclear reactions is a preferable and ideal approach, since neutrinos have very limited interactions, barely interacting with anything at all. To put into context how difficult it is to detect these elusive particles, trillions of neutrinos pass through the Borexino detector with each passing second, though only a few dozen are detected within an entire day. This is done by looking for small, faint flashes of light produced as they decay in a dark 300-ton tank of water. Having poured decades of research into this, it was not until the last 5 years that big strides were taken, as the detector was made even more sensitive. This was done by blocking external sources of radioactivity. This makes the chamber of the Borexino detector the most radiation-free place on Earth. From this research, we can see the first ever piece of evidence confirming that the long-hypothesized CNO cycle is taking place in the Sun and other stars. This can push us to uncover more about how the cores of our stars are composed, as well as a bit more behind the formation process of heavy stars. This one tiny type of particle that has been discovered has had a major, momentous impact upon the world of physics as we know it. US detects huge meteor explosion. Meteors often sound like something confined to the wonders of sci-fi or the horrors of an action movie, though in reality, we see meteors more often than you might think. In 2018, one particular meteor stood out, making an impact on us all. NASA managed to spot a fireball in the atmosphere of Earth back in December of 2018. This explosion is thought to have been the second largest of its kind that we have observed within the last 30 years. Despite the staggering size of this meteor, it went somewhat unnoticed until early 2019. It did not wreak havoc on a city or town, but instead blew up over the Bering Sea near to Russia's Kamchatka Peninsula. Calculations suggest that the force with which the meteor exploded was 10 times that of the Hiroshima atomic bomb. This might not sound all too momentous, considering that there was another comparable meteor just 5 years earlier, but the planetary defense officer at NASA, Lindley Johnson, commented that a fireball meteor of this size is only expected 2, maybe 3 times within a century. Despite the general public not being too aware of the event until a few months later, thanks to the scientists hard at work, we do know that the meteor entered the planet's atmosphere at a speed of 20 miles per second, and at an angle of just 7 degrees, making it an incredibly steep trajectory as it sped towards Earth. It exploded just 25.6 kilometers above the Earth's surface at about midday on December 18th. The impact energy as the meteor broke apart was 173 kilotons. As it was over the Bering Sea, it did not have the same impact as it would have over a populated area, letting the meteor skim past the news readings. Thanks to military satellites, we were able to anticipate the event in advance, with the US Air Force notifying NASA. The fireball entered not too far from routes that commercial planes fly through when traveling between North America and Asia. Having that bit of notice and an awareness in advance allowed us to keep a close eye on the meteor, both for scientific purposes and in the interest of keeping people safe. If we continue to improve our surveillance, perhaps we can make this seem like even less of a threat in the future. Supernova shrapnel star speeds out of the Milky Way. In 2021, news broke about the runaway piece of star that has been fired out of the Milky Way galaxy at 2 million miles per hour, 1,000 times quicker than a bullet, after it had survived an explosion. This fragment of a star is being described as star shrapnel. It's a metallic object estimated to be around a fifth of the size of our Sun. It seems to be flying out of the Milky Way, with some describing the motion as being slingshotted. According to experts, it's an example of a rare breed of fast-moving stars, with this one being left over from a supernova. Researchers believe it is a piece of what was once a massive white dwarf star that seems to have managed to survive as a small chunk following the star's explosion. A team of astronomers from Boston University believe that looking into this star shard, named LP40365, could enlighten us about the troubled pasts of other similar stars. It's an incredibly unique thing for us to observe, with us only considering in the last few years that these types of stars could exist at all, according to Adelia Putterman. Putterman and her colleague Hermes analyzed data from NASA's Hubble Space Telescope and the Transiting Exoplanet Survey satellite. The pair then analyzed the speed, rotation, and brightness patterns of the star to figure out what precisely was going on. The star was rotating every 9 hours, which is somewhat slow for a star fragment having just made it out of a supernova. So it's undoubtedly a clue as to what is happening cosmically. There is still more to unravel, though now we are detecting and analyzing the behavior of stars that a few years ago we did not even know could exist. The scientific world is truly remarkable. As the scientific world continues to make advancements, it's truly phenomenal the things we can uncover. But what do you make of these incredible discoveries? Be sure to let us know your thoughts in the comment section below and help us by growing this community while working to solve these unexplained mysteries. Thank you for watching, and don't forget to subscribe for more videos.